Yeah, hello everyone. First, let me introduce myself. I'm Praveen Mohad Prasad. I work with AWS as a specialist technical account manager. I focus on the analytics services of AWS, especially on the operational side. So, like once people onboard into analytics services, especially OpenSearch, I work with the customers to make sure they have an operational excellence journey. So that's my primary responsibility with AWS. And on the other side, I do a lot of experiments, research in ML search. So that's something I do I'm curious about, and I see and I love how the field is evolving. The information retrieval field is evolving throughout the space. So I just want to take this time to bring in a conversation like, is single vector enough? So we all know vectors and vector search perform better than traditional search methods. Yeah, like traditional search methods, they lack in understand the semantic meaning. They just match by overlapping keywords. So, so if there is no exact keyword match, then it's not going to give relevant results to the user. So that's where in vector search, these vectors are able to understand the meaning of queries and documents, because in that high dimensional space, they have a lot of attributes, and these attributes put your objects in that as a single point in the high dimensional space, and you retrieve similar documents using this approximate nearest neighbor search. But so when we do vector search, what we all do is we take the documents, we index them offline, like one vector per document. And then during the online phase, we just again get one vector for the query, and then we do a vector similarity search. So my question is, having this as the vector search process, how would this particular query work for your single vector search, where you have a question something like, who liked Alice but not Bob? So if you look at this query, there is like two important things, right? So one is the document should bring up, whichever is relevant in favorites of Alice. On the other hand, the document should also handle that it's not talking about Bob anywhere. So I just wanted to ask, like, what do you think, or how do vector search, single vector search, work for this particular query? Any questions? I mean, anything that you can raise your hands.
That's the only slide. I hyped up the slides, you guys.
Okay, if that's the only slice and is single vector enough, I think I am really have a lot of things to say, because just 1 week ago on LinkedIn, one Google publication is exploding because it says single vector is not enough. Okay, they said that theoretically they proved that single vector's limitation is hardly bounded by the dimension. So yeah, everyone's now shouting on LinkedIn, even now, especially Hugging Face. So, okay, now let's do multi-vector, right? Because we can do covert to embed the sentence into 1, 2, 3, 4, 5, 6 plus 1, and I think it's like almost a 9 tokens, okay? And then if we have 9 tokens, we have 9 embeddings. And that is enough. That's Google's paper. But my team, especially my former intern, is shouting, okay, why multiple vectors? Let's just do sparse. Because sparse can have even unlimited dimension, right? I can have all the keywords or even some meaningless tokens be having a weight into a super large semantic space that is can also be naturally retrieved by BM25 engine. So that is a wonderful state, right? So actually this is a really interesting thing. But I think still I have some kind of deep dive to that paper. We are still arguing in our small community whether this Google's paper is making sense or not. So as I stated out, let's pause a little bit on advertising multiple vector search or sparse search. Let's first get clear whether this Google's paper is making sense or not. But it's very interesting. Okay, I will be really quick. In CGIR, because I joined the CGIR this year in Italy, the special interest group of information retrieval. In 2021, the first paper of multi-vector search is introduced, and it's nearly rejected. Okay, it's just barely they finally present. And okay, in 2022, 2023, 2024, even 2025, all the best paper of this conference is about multi-vector. So it becomes super, super hot. But I wish next year maybe the best paper is about sparse encoding. But actually, we can definitely answer this question. Simple vector is not enough.
That's a great point. Before I give it to you, John, so just to show some research works and whatever he said, this is one of the research that was conducted, like, I think it was around 2023. And this is where they had a data set called Beer. And Beer has a group of data sets which is coming from multiple domains. And what they found is the first arrow, which is like the down, which is TASB, that is a single vector model. And that was actually being easily outperformed by the traditional keyword search, BM25, with a cross encoder on top of it. And on the other hand, if you see the third bar from the left, Colbert is a multi-vector model that was also performing better than TASB, which is a single vector model. Yeah, this is about, yeah, we have this neural sparse as a separate discussion, but this is on vectors. And this was like another research that just was a research paper that was released last year. And they, again, brought up this topic of, is single vectors really enough? And that's where they had like 50,000 documents, and they created a new data set with this 50K documents. And with 1K queries that they tested this. And all these 1K queries were similar to the ones that I shown you, which had this complex relationships and conditions, logical OR conditions, and so on. And that's where they found, again, single vector embedders underperform. BM25 was better than the single vector search, and also multi-vectors was performing better than single vector search. So we have like sufficient proofs that single vectors are not enough when your queries are complex, and there is no wonder that your numbers will come down when you use single vectors, and you have a use case where you deal with complex queries. So that's where, the space of multi-vectors is evolving a lot, which means for every single document and every single query, you're gonna have multiple vectors, and then you're gonna do a similarity search between those multiple vectors of queries and multiple vectors of document. And since we're gonna have multiple vectors for your queries and documents, we're gonna have like all the tokens relationships understood, and every token is compared against the query and document, and all those logical conditions and the complex relationship will be easily understood, and the final results are going to be much better than the single vector search. So I have a quick demo that I can show you, but if you want to learn more about this particular vector space and how to implement this open search, we are having a session tomorrow on the same particular topic, multi-vectors in OpenSearch, in the same room at 10 o'clock. If you want, you can come and join. I can quickly show you a demo, so how this basically works. That's it. Right. So as you see here, this is the vector search on a small retail data set and this vector search is happening based upon multiple vector approach that I told you. And as you see here, like for the query, based upon the query, like I received augments and also I get some highlight snippets. And this is basically coming because of the token-to-token match. So basically, you can make your vector search explainable when you have multi-vectors. Similarly, like how you put your highlighting on your keyword search, like which tokens got matched and which tokens did not match. With vector search, you can do them. So basically, you are making vector search explainable. Yeah, that's it. Feel free to join tomorrow's session.
I think it's a really, really great question, but I think it's the wrong question. So you're looking at a relationship here, right? Who likes Alice, but who doesn't like Bob? So there's pairwise relationships, and then there's a hierarchy of relationships, the liking and the disliking, and what is the relationship between them. Back when I was a baby grad student, there was a ton of work on similarity that has to do with attribute-based, so flat similarity versus hierarchical similarity. And if you go to similes, there's a famous simile, my doctor is a butcher, my butcher is a doctor. Okay? If similarity was flat, then they would be equivalent statements. But we all know they're not equivalent statements, right? There is something that happens that is about taking a hierarchical set of attributes and mapping it from doctors to butchers or butchers to doctors that works differently. So that's a lot of background to say, I think the question is a flat, because all of the embeddings, you're flattening. You're coming down to a single set of attributes and there's no relationship between them. So is that the right way to tackle a question like, who likes Alice, but who doesn't like Bob, right? And I think the answer is no, and I don't know of anybody, apart from the fact that all of the models are hierarchical, and so you get that kind of hierarchical flavor in there, especially in language generating models where you have these multi-layers. Why do you need multi-layers? Because they represent different levels in the hierarchy, right? So I think it's fascinating. Thank you for bringing it up. I think the question should be, is a flat representation the right representation, or how do we do hierarchy? There, I got on my soapbox for a bit. But.
Yeah, I mean, one of the other, I totally agree with you, John. So one of the other statements in the same research paper was that, like, for complex relationships, even the multi-vectors and the sparse embedding vectors was not enough. And graph-based relationships and graph-based data structures was rather used to make them work. But yeah, I mean, this is just a start of this phase where we should also think beyond single vectors and move to areas where multi-vectors make sense, like wherever multi-vector makes sense.
We're focused on too few tools. There's so many things. Why is everything a vector? And it's a useful tool, right? They're cool. They do lots of cool stuff. Why are we focused on BEIR? BEIR has, for example, no e-commerce data sets. So it's useless for most of our customers as a measure of quality. So, we need to broaden our perspective a little bit. And I don't think, will I be getting to talk or not? You don't know yet. Well, foreshadowing, just saying, you need to be smart about how you use multiple tools. How's that?